we come to Module 2, which talks about IT architecture. In this, we will look at the blueprint of IT assets in a firm's IT portfolio, and we'll talk about what they do and how they interact. So the first, we talked about IT, spent a lot of time on the first module on IT strategy, and now we are moving on to architecture. So let's look at some of the jargon we're going to use. The first name is IT architecture, and as I have mentioned earlier, it is a blueprint of IT assets in your portfolio, IT portfolio, and we are going to talk about what they do and how they interact. Enterprise architecture is how a firm's corporate IT applications or apps, infrastructure, and data are organized. Operational performance is an IT asset's fitness of purpose, security, and maintenance costs. Evolvability is how easily an IT asset can do unplanned things. DNA analogy, the architecture is usually long-term, the impact is long-term, and we are going to talk about it being the DNA of a corporate firm because it constrains how it can be changed over life. We're going to talk about the architectural trade-offs, which is operational performance versus evolvability. So whether you want to be flexible later or efficient right now. The application architecture, how an app is divvied between the user's device and more powerful server machines. And finally, we're going to talk about the data architecture, how your firm's data assets are organized. So we have known for some time that IT systems are costlier to keep running than to actually get. They do not die when you're ready for them to do. $1 spent on an IT system, you spend about $7 lifetime in running costs. They outlive their intended lifespan by about 200%. A lot of firms spend a lot of time over the initial spending, but they overlook how IT's choices hurt their strategy later. If you start thinking about IT architecture as the technological DNA, which is irreversible and preordaining, then you start thinking about how to build your IT systems very differently. Information technology is not really designed to evolve, and therefore it handcuffs your strategy. So the impact is both operational and strategic. IT architecture choices of today sow seeds of what you can do tomorrow. You take shortcuts today, and that's paid later in maintenance costs and lack of business agility. Now, if a non-IT manager is not part of making decisions about information technology, the strategic consequences of your IT decision escape a firm's radar screen. So it is important that non-IT managers know enough to actually have a conversation with people in the IT department. So let's take an example. So the examples of how architecture affects the future of the organization. Let's take the example of Facebook versus Skype. Every new user costs Skype about 5 cents, whereas Facebook's about $5. And the difference keeps rising because every time Skype adds a new user, because of its architecture, it actually strengthens Skype, whereas Facebook, it actually overloads Facebook. Siri, for example, was able to enable voice recognition, and this is something which has been around since the 1950s, and people just couldn't get hardware devices which were powerful enough to do voice recognition. And so the Apple essentially quit trying to use the user's device to do the voice recognition and instead hooked phones to remote supercomputers through the internet, and that allowed your device to access huge supercomputers. Let's take Obamacare's website. The main issue with the implementation of Obamacare ended up not being the healthcare law, but actually how the website was implemented. The 2 billion system was set up to handle about 50,000 simultaneous users, and the first day it actually ended up trying to we had about more than 20 million people trying to access it, and that essentially because it wasn't scalable, crashed the website. Netflix is able to stream more than 100 million viewers over 190 countries because of its distributed architecture. Delta, again, Airlines, was able to change its infrastructure without having to retrain 80,000 of its employees. Same thing with a UPS. What it does is they made a decision in the 1980s on how they're going to handle their IT architecture, and was able to use a single package database worldwide. Helps ensure no package gets lost. UPS also operates the world's largest private aircraft fleets and cellular network. There is, let's take Napster, which actually started digitizing music, but because of its distributed architecture, remember we've been praising distributed architecture, but Napster's problem, because of its decentralized distributed architecture, was sued and then went out of business. We have Target, which lost 110 million customers' data around Christmas season, and it was about $42 million credit cards across its 1,800 stores during the 2013 Christmas season. It had no single point of vulnerability, but insufficient separation of its IT financial systems with its refrigeration support systems. The huge security breach was due to poor firm-wide IT architecture. Google keeps needing to add more servers because of its architecture. Its monthly electricity bill exceeds more than 250,000 homes. Take a look at Delta and the IT systems at Delta. So this was the old Delta IT portfolio. Now, Atlanta-based Delta Airlines is the oldest and one of the largest American airlines in operations. Its IT systems were costing so much that they were wiping out income in an industry known for very, very small margins. Delta was making losses year after year, and it was well on its way to declaring bankruptcy. It was running about 30 major collections of IT systems, none of which talked to each other. Each of them were required a staff of about 100 people, and it cost Delta about $700 million a year just to keep them running. A simple answer such as, at which gate does Flight 74 arrive, could give you 17 different answers depending on which IT system you asked. If a flight control tower changed the gates, the flight crew, maintenance engineers, Baggage handlers and customers did not receive timely notification. All of this kept planes on the ground longer than was needed, which is a surefire way for airlines to lose money. Airlines are estimated to lose about $500 for every minute of delay in departure. Losing bags was another expensive proposition. Each lost bag or retrieving a lost bag cost Delta about $150. So Delta started looking for a way to fix um, their IT infrastructure. Um, the interim CIO, Charlie Field, essentially said that the central nervous system was broken. One physical part of Delta did not know what the other part was doing. And so it basically built something called the Delta nervous system, which cost Delta more than $2 billion in 2016 and took about 5 years from 1998 to 2003 to implement. The $2 billion was in 2016 dollar terms. It looked at eliminating inefficiencies from every aspect, linking customer scheduling, ticketing, employee database, and they did it in a very smart way. If they replace the entire system, they would have to retrain um, their 80,000 employees. So what they did was, instead of scrapping the old applications, Delta kept the old applications as they were, which they did not have to then retrain their employees. But then they connected all the old applications to a middleware which accessed a centrally accessible database. So from the front end user's perspective, nothing changed. And that is usually in a lot of IT implementation the problem. And it was the back end that completely changed. So they kept their same applications, which baggage or gate or towers have been using, and they did not lose all these years of institutional knowledge on how to work these apps. And yet these apps essentially ended up getting more data, better data, timely data, and consistent data. Now, doing this is a lot harder and probably more expensive than replacing the entire system. But because they did it, it helped Delta a lot. Architecture serves the same purpose for information technology projects as homeowners who want to build their house. So what it does is it reconciles what is desirable and versus what is actually achievable. So here's an example that illustrates the problem. Your homeowner's intent is like your strategic aspirations, and the home you want to build is like your operational strategy. And then you start prioritizing needs, and these are your homeowner, the line functions in the business, and you build your architecture for your house or IT architecture, and then you start looking at costs, constraint, which basically reduces the possibilities, and that's the same thing that happens in IT architecture. As you all know, when we are thinking of a house project, um, we look at all the possible things which are desirable, and then we start budgeting them, and then we figure out that while it'll be wonderful, it's not necessary. And so, but this is a conversation which needs to happen. And finally, you start with the project, right? And essentially your IT project or your construction to the home should match the intent or the strategic aspiration. So we can look at architecture as the DNA. When we use this word architecture as a DNA, what we are really saying is that it's not easy to change once you build that IT architecture in. So when you figure out your IT architecture, it essentially establishes certain traits in IT systems which are largely irreversible, or they can be reversed, but the costs can be really prohibitive, and it influences how they can and cannot evolve. Now, a blind spot for the line functions are the technical decisions, but IT specialists are not really do not understand the strategic consequences of the technology decisions they make. And so again, we reiterate the ongoing conversation between IT managers and non-IT managers. IT architecture, the choice of IT architecture is going to be a choice among trade-offs. You're going to maximize one desirable attribute which will compromise another. Non-IT managers must understand so they can proactively make such trade-offs rather than recognizing them after it's too late. Even when you do not make a choice, you are actually making a choice. By not participating in IT architecture decisions, you're choosing to delegate them to IT unit. To contribute your business acumen to the conversation, you must know just enough about IT architecture to communicate your business vision and negotiate the trade-offs. So taking an example here, here's you're looking at the strategic component. The strategic part really, if you don't have a conversation, will end up being visible later. And how evolvable an IT architecture kind of puts in the inflexibility of the structure. And you essentially have operational consequences about security, maintainability, how fast and reliable it is. And that happens immediately, whereas the strategic impact happens long term. So if you look at that, your operational consequences are immediately visible, whereas your strategic are visible later. And without non-IT involvement, the operational part becomes the sole focus, and strategic part is not taken into account. So as you can see, here are some costs involved of the operational and strategic consequences of IT architecture. So if you look at that, the figure we talked about in the previous slide, we have operational performance, and consequences of fitness of purpose, which is how responsive and how reliable it is. Security, how vulnerable it is to malicious tampering. Maintainability, how cost effective can you make incremental improvements, keep it functioning smoothly. These are operational performances. And the strategic performance of scalability, how cost effectively can you grow with your firm needs, and evolvability, which is can it adapt to do things it was never designed to do. So good architecture will essentially balance these issues of economical performance today and then the changeability tomorrow. It fulfills today's requirements but plans for tomorrow's expectations, and this gives you a good understanding of why some firms' infrastructure is more adaptable and therefore can harness new innovations a lot faster. And it is again the conversation between IT managers and non-IT managers which bring about this coming of being of good architecture. So if you look at the corporate IT architecture, we are essentially, and look at it as a blueprint for IT assets, we are kind of looking to see how they fit each other. Firm-wide organizing logic, a logic of three classes of IT assets. And the three classes are IT infrastructure at the bottom, data, and applications. Now, the infrastructure constrains what the applications can do, and the applications then shape what kind of data you get. And this is very important because end of the day, this is about getting data and converting data into actionable intelligence. IT complexity can paralyze how a business can work because business processes are embedded in information technology. And this is a patchwork of decades of generations of technology, which are connected in very poorly documented ways. And there's a whole ripple effect that actually then stifles change because you don't know how a change in one part of the system actually affects another because it's been added on a regular basis, and this brittleness of your IT systems actually becomes a competitive liability. Inflexible IT becomes an inflexible business process which cannot adapt to the changing market. So IT does not become a catalyst for business agility, which it's supposed to be, but an impediment for business agility. So here is an example. We have three different apps which are connected through the basic architecture. This was the old system. But as systems evolve, you have app 1 then which directly talks to app 3, which talks to app 2. And then app 2 is talking to some other application or different system altogether, which there's no documentation about. And if you need to make changes in app 2, this is going to be a mess. App 1 sends data somewhere else. So you see a clean architecture earlier, then evolves into this messy IT architecture without thought for the future. And this actually causes a lot of problems. So simplicity becomes really the most sophisticated method. It's an antidote for complexity, and you have to impose simplicity. A good enterprise architecture makes complexity manageable by one, increasing autonomy of IT assets and making integration easy. The key idea here is to lump things that change for the same reason at similar speeds, and applications that change faster to foster business agility, and infrastructure that changes slower and lowers cost. So essentially, we look at applications as one layer and infrastructure as a separate layer. And therefore, infrastructure is focused on cheap reliability, and applications are the ones where you are going to actually work on rapid change. And so you got to think about architecture as Lego-like blocks, or people talk about modular, being very modular. Business processes are hardwired into their applications. And when you do a modular approach, you bring in simplicity and adaptability. Conforming, and so we talked about Lego studs, which allows freely changing any brick and attaching it to others to create more complex structure. Apps which are relatively interdependent interoperate via explicit interfaces that permit tweaking and gluing an application back into the portfolio. So this is, and as people like to use these words, this is plug and play versus instead of plug and pray. And your infrastructure essentially serves as the electric outlet, and it interoperates with multiple devices like electric outlet. You can use a toaster, coffee maker, vacuum. You can plug and work on it. And so you have the advantage of ability to tweak your applications with interoperability, and it does not affect the others. It also makes complexity more manageable. And also then a problem in one application does not destabilize the other. So this permits business agility because any change in a particular line function, we can innovate with the IT application without sacrificing firm-wide integration. So here is an analogy to a Paris architecture where you're looking to preserve old assets and adding new ones. And you can look at applications, infrastructure, and so you see here's an example of an analogy of a city versus IT infrastructure. And with this, we stop the first part of this lecture, and we will start the second part of this chapter in the next lecture.